Okay, now we can share. Okay.
Okay. Have you tried the cases?
Yeah, I tried it, the cases, and it's working right now.
Have you observed any changes? How the
Like,
lid driven cavity flow is changing with respect to increasing the velocity and increasing the
yeah, yeah,
velocity. So
yeah.
what are your observations?
So, like, as we increase the velocities, I can see a different counters and velocity counters and pressure counters. Like,
Yeah,
yes.
yeah. That we you can observe, but what is the reason behind it? Have you observed that one? So while increasing the velocity, the
Uh-huh.
cavity which is flowing here. Let me ask for the
Remote control, you can.
yeah
Have you asked?
no. So here is it.
This
Request.
over the top layout
Yeah,
annotate.
yeah, yeah. Sorry. Yeah, give me the access.
Yeah, yeah. You have the access right now.
So when we increase the velocity, the cavity which is forming here, the recirculation zone.
Mm-hmm.
This is
Research.
this is the recirculation zone because the velocity is flowing from left to right. So the flow will be the arrows. If you can see here, glyph for this one.
Yeah.
Orientation array will be our velocity, and if I can hit apply and close this one, decrease the seats to 1000.
Yeah.
Yeah, see, so the recirculation zone, the flow will be at the initial stage, the flow is like this, stationary at the zero time step. So after the time step, the recirculation zone is forming here. Okay, this is the recirculation zone here. So the recirculation zone will shift from left to right with increasing the velocity
Oh, okay.
because the shear will be more. The shear will depend upon the velocity of the flow.
Uh-huh.
That's why. So if you increase the velocity, shear stress, we can see the formula, right? U in mu du by dy.
Yeah, and you already you
So
are
it
right.
directly proportional to velocity. That's why. So if you increase the velocity, the recirculation zone will shift from left to right. So this is the how much velocity consider. This is velocity one, right?
Yeah. Yeah, velocity.
So if you can open the 10 velocity, the recirculation zone will form here. And here also there is a little bit of recirculation zone that you can view here
Yes.
uh, with the streamlines. I will change from line source to point source and increase the radius
0.8. Yes, 0.082.
0.08, right? Yesterday.
Yeah.
Increase the number of points. I will increase to
1000. Yeah.
10,000. So it will be much denser.
Yeah.
And if I close, sorry,
Yeah.
and if I close the, so see, and the here also you can observe, where is the zoom? This is also a recirculation zone.
Yeah.
Here also little bit. So you
Uh-huh.
can find this lid driven cavity problem. So this is the benchmark problem for the any CFD code validation. So whether it is working or not. So you can observe this type of changes in papers if you can find it in any general papers with increasing velocity, how the lid driven cavity is varying. You can see it in the papers. Okay,
Okay.
general papers. So today, have you gone through about the block mesh did mesh? I have already seen here. You did finer mesh on the above side.
Yeah, I did. I tried to change the different meshing, like the top and the bottom, and it was working. It was
Oh,
working. Yeah,
okay.
yeah, it was working.
So so open this block meshing file of this one. So I will quickly tell you how it will be.
Okay. This one, and we first close.
Yes, yes, close it.
We Gedit. Yeah, Gedit block mesh. So basically, I just yesterday
So
we
have you understand the this thing how it is coming like simple grading?
yeah, I just understand it right now.
So
Yes.
why you given 0 to 0.2 how it is changing?
So
What is this 0?
basically is if I give a 0.5, so
Uh,
the cell at the bottom gets finer. So it's basically the ratio between the bottom cell and the top cell. So in this case, 0.2 is basically making the finer mesh at the top. So it's basically yeah. So this is basically the ratios between the two edges, like
yeah.
so.
So there is a name it for this called expansion ratio.
Yeah.
So okay. So let me share my screen. We will go about a little bit about how we should give the vertices. Okay. Have you changed it with the change in the vertices in the block mesh did for the any other case files? So
No, not
not yet,
no.
right? So okay. So okay. You stop sharing. I will show the notes.
Yeah.
So it will be better. Okay. Let me share my screen.
Yeah.
It's asking for request.
Yeah. Okay.
Okay. So are you able to see the screen?
Well, no, right now, no. Yeah, right now, yes.
Okay. So here, so this is our block, right? So
Yeah.
block should be start from 0. 0, 1, 2, 3, 4. 1, 2, 3. It has to be start from the same line where it is starting. This is considering as the origin. Okay. So other phase should also start from here only. 4, 5, 6, 7. So these are the vertices for the 0, 1, 2, 3. So parameterization, uh, inline calculation. So you have to go from here on the x, y, and z. X
Mm-hmm.
minimum, x maximum, y minimum, y maximum, z minimum, z maximum. Okay. So this is simple grading. So this is x minimum. Delta x, x minimum this starting point, and this is the x maximum point. So delta x will be x2 minus x1. Okay. So length of the x direction, this block is x max minus x minimum. Nx will be at a particular cell. Cell length
Yeah.
will be Lx by delta x.
Yeah. Total number of cells in that direction. Yeah.
Yes. Yeah. Okay. So here it indicates vertices indicates x minimum, y minimum, z minimum. Okay.
Okay.
Particular point. So block you know right for this is hexagonal mesh. So block will be 0 1 2 3 0 1 2 3 4 5 6 7. It should be the same order. Then only it will patch. So if you give 0 1 2 3 0 1 2 3 and 5 6 7 4, it won't work. It will give the
Yeah.
error. Yesterday we saw right. So simple grading means uniform meshing. So there
Yeah.
is nothing here. Same throughout the direction in a single direction. So
Yeah.
if you want to increase the gradual increase in the size along the mesh. So what happens is here in the lid driven cavity which we solved, let's take the example. So we want to analyze the fluid flow on the upper part only, moving wall.
Yeah.
Basically, we want to analyze the fluid flow on the moving wall because that is only affecting the fluid change. So remaining areas we don't need to study. So if you give finer mesh without even needed, it will take more time for the simulation.
Yeah.
So what we have to do in the below part on the fixed wall side, it should be uniform meshing or coarser mesh, but along around at the top where we need the analysis, at that point we need finer meshing.
Yeah.
So for that we have to use multi-grading. This is simple grading. Currently in the uniform size, it will be 111 only. So that will be simple grading. So if you want to use finer mesh on a particular point, we have to use the multi-grading. So expansion ratio, this is what I'm talking about. So expansion ratio is the outermost. So x2, next level by initial level, xn. So if we, this is the delta x1, delta x2, till it goes to delta xn. So
Mm.
expansion ratio will be delta xn by delta x1.
Yeah. The last.
Final, last to first. So if you give 4, let's take the expansion ratio is 4. We have given 4. So in that case, you given 0.2, right?
Yeah.
So on that time, what happens is xn by x1 is 0.25. So xn will be 0.25 of x1. So that will, it will finer along the x direction.
Yeah.
So here in this case, it is 4. So delta x1 will be 4 times of delta x1. So here you can see that the gradual increase on delta x in the x direction. Okay. So you
Yeah.
given this case
Yeah.
0.25, the delta x1 will be 0.25 of so here see, so 0.25, that means delta xn is 0.25 of delta x1. Okay.
Uh-huh.
So here on the y side, this is on x side. Okay. The first is
Yeah.
x, second n is y. So y we are giving is 4. That means delta yn is equal to the 4 times of delta x1. That's why we can able to see here. So along the x direction, it will goes finer. Along the y direction, it is going for coarser.
Yeah.
Z direction, it will be uniform.
Yeah.
So okay. So if you want to try this one, so
Yeah.
I want finer mesh on the edges on the four sides and coarser mesh or uniform mesh on the middle. So what are the ideas you are getting to do like this?
Mhm. So, yeah, then probably I think we divide the cells like giving it like 0 to 0.2, divide it into 4 or
Yeah.
5. Yeah,
So
something.
yeah. So what we have to do is we have to create a single block into four blocks.
Yeah.
So I will divide on the off and I will divide on the off here.
Yeah.
So I have to name the vertices. Okay. Have to
Okay.
we have to do it. That is the one way of doing. So that will take time. Actually, I want you to try that one, but I will show. Uh, I should have the case file of that one. I will show that, but we are not doing that right now because it is time taking. That is actually not needed as well.
Mm-hmm.
Let me see if I have the image or not. Yeah, here.
I cannot see your screen. Probably.
Oh, sorry, man. Where is it? Zoom, right?
Yeah. Wait.
Where? Yeah, are you able to see?
No, no. Yeah, right now. Yes. Yes.
Yeah, here, see, on the edges, it is finer.
Yeah.
This edges, it is finer, and in between, it is coarser, like uniform or coarser, you can think. So, what we can do is for this problem, I want you to try like this. This is not the only way to do this problem. So, we can divide this whole block into four blocks. So, that is on the middle, there is one block. On the vertical line, we have one block. That means this is one block. One, two, three, four. So on the four blocks, we can give grading expansion ratio, and we have to do it. We can do it.
Okay.
So let me show the block mesh data of it if I have. Yeah, see here the blocks indicating the number of blocks. Okay.
Yeah.
So here it is 4 blocks. I created with 4 blocks. So from the vertices, I have to create the blocks. This need little bit of time for you to understand. So let me show how I did it in the PPT or somewhere. Mm, I think so. This is one block.
Uh-huh.
Mm, So this will be of our front view. Okay.
Yeah.
So draw. I will keep my notepad here. Here it is, man. Yeah. Okay. So here it is starting from 0
Yeah.
and the length will be 1. So this will be of my 0
Yeah.
and 0.5. This will be my 1 and 1. This is our my 2. So from here I can see. So 1 0.50. That means
Yeah.
so
Yeah.
here 3, 4, 5 and this will be my 6. This will be 7. This will be my 8. Okay.
Yes. Yes.
And I there is a shortcut for the outermost boundary. So what we have to do is we have to create a pen paper, but I will tell you the shortcut on the back side of it. Okay. So this will be my 9. Whenever you are trying to create a block, write like this. So this will be easy for you. In the same order, you have to write. This will be my 11, 12, 13, 14, 15, 16, and 17. Okay.
Yeah.
Did we miss anything? 14, 15, 16, 17. 5, 6, 8, 9, 10, 11. Okay, 17, right?
Yeah.
So the blocks will be first one. This will be my first block. And 5, 4, 7, 8. So this will be my second block. And 1, 2, 3, 4. This will be my third block. And this will be my fourth block. So see how I created the blocks 0, 1, 4, 5. Okay. 0, 1, 4, 5. So this is in the anti-clockwise direction.
Okay. Okay. Okay.
And the back side of it, of the block, the other face, front and back, right? So this is my front and this is black will be on the same direction. 9, 10, what is this? 13 and 14.
Yeah.
Okay. Forgot about this thing. I will tell you. So this is it. Okay.
Oh,
Okay. So similarly on the second block, 5, 4, 6, 8. and my this is my front side, and back side will be 14, 13, 16, 17.
Mm.
The order should be anti-clockwise for the everything, every block. We have to follow the same one. So
Okay.
on the third block, it will be 1, 2, 3, 4, and 10, 11, 12, 13. And the fourth block will be 4, 3, 6, 7, and 13, 12, 15, 16. Okay.
Uh,
S- So how I created, these are the four blocks. So I want uh, these cells, you can give it uniform or else you can give it for variance as well. So this will indicate the number of cells. Okay. So in the block, in the X direction, I need 20 cells. That means these are 20. Like this, I need 20 cells.
yeah.
On the Y side, I need 40 for this
Mm.
block. You can give it uniform as well. There is no problem with it. So this indicates that one. So number of cells and simple grading. So I need finer on this side and coarser on this side for this block, because I need finer along this one, right? Along these lines. On the
Yeah.
starting need, I need a finer ones. These are all finer I need.
Uh-huh.
On the middle, I need coarser ones. Okay, so for this block, if I give my expansion ratio in the X direction, so the action will be more. So it will be positive 10. So here the 10 indicates the action, the final length action value is 10 times of x naught.
Yeah.
Okay, I understand. In the similarly in the y direction, this is our middle, but here also I need coarser one only. I need finer on the above side. So in the y direction also I give it as 10. So the yn for this block is 10 times of y naught.
Mm.
Okay, so for the similar blocks, we have to follow the same thing. So in that x direction, it will be same, but in the y direction, it is 0.1. That means the delta yn of second block is 0.1 times of delta y naught of second block.
Yeah.
So we have to follow this one. So I want you to try this one. So here the difficult part is that walls, while you are defining the boundaries, right? These are the boundaries. The
Mm.
yellow, green color one is our boundaries. So you have to you want to define the boundaries vertices, front and back. Okay. So moving wall. This will be my moving wall. So moving wall, what are the faces? Type is wall. Okay. Moving wall, the type is wall. The faces will be 8, 7, 16, 17. So this will be anti-clockwise.
Yeah.
Okay. So 7, 16, 7, 16. Sorry. This will be clockwise. 8, 17, 16, 7, right? Eraser is there. Okay. I will do one.
The razor is on the left of the black pen that you are having.
Yeah. Yeah. Here, the moving wall is 8, 17, 6, 7. Okay. So I followed the clockwise direction.
Clockwise or okay, yeah.
Clockwise
Clockwise.
direction. So here also I have to follow the clockwise moving wall. Okay.
Okay.
So 8, 17, 16, 7, and 7, 16, 13, 6. 15, 6. This is 15.
Mm.
The fixed walls. Here comes the trick. So the type of walls 5, 14, 5, 14, 17, 8. So this will be our clockwise.
Okay.
Okay. So everything is in the clockwise direction here. 0, 9, 14, 0, 9, 14, 5. This side I defined.
Okay.
Okay. And 3, 6, 15, 12. 3, 6, 15, 12. And here it will be 2, 3, 12, 11. And bottom is also we have to define. So it will also 0, 1, 10, 9. 1, 2,
Yeah,
11, 10. Okay.
yeah. I think I need to draw this one. Yeah,
Yeah, you have to draw it in the cubical way, cuboid, then it will
uh,
be easy. But if I draw it on the pen, how can I show you?
okay. Yep. Okay. One, nice. One, okay. You divide this into 0, 1, uh, yeah, 2, 3, 4, 5, 6, 7, 8. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8. Then you start the 9 again from the same 9, 10, 11, 12, 13, 14. Can you share the screen again? I just want to
Okay.
see your
Oh,
vertices.
yeah,
Yeah.
okay, okay. Sorry,
Mm,
my Are you
yeah.
able to see?
Yeah, yeah, yeah. Yeah, I'm able to see 15, 16, and 17. Yep, 17. 1, 2, 3, 4, 5, and yeah, 12, 13, 14, 15. Yeah, you're right. Now the first cell, first wall is like you say 5, 4, 5, 14. That's the back of it. The 5, 14. Then it should be 5, 14, 17. Mm-hmm. 5, 17, 6. No, which one is 5, 14, 17? Okay, okay. 5, 14. Are you sure like the 5, 14? Yeah, you're right. You started from, okay. Let's start with the moving wall. I just want to see.
Okay.
Yeah, 8, 17, 16, say 8, 17, 16, 7 is the one portion. Okay, 7, 16, 15, 6. This is clockwise, I guess. Yeah, it's clockwise. Then you are coming to the fixed wall. 5, 14, yeah, 5 here. 5, 14, 17, 8. Good. Then 0, 0, 9, 0, 5, 14. 0, 9, 1, and 10. It should be 0, 9, yeah, 5, 14, 7, and 0, 9, 14, and 5. Okay. Yeah. 0, 9, 14, and 5. Okay. Yeah, 0, 9 is the left hand side. Okay. And then 3, 6, 3, 6, 15, and 12. Okay. Yeah. 3, 6, 15, and 12. And 2, 3, 12, and 11. Say, okay, you're right. Okay, 0, 0, 1, 10, and 9. Okay, 1 to 11 and 10. Okay, this one. These are the, okay, now you say front and back. 0, 5, 13, and 0, 5, 4. 13 is back. 0, 5, 4, and 1. 5, 4, and 1. And then 5, 8, 7, and 4. 1, 4, 3, and 2. Okay, yeah. 4, 7, 6, and 3. Okay, that's correct. And then we have a 9, uh, 9, 10. You're right. 9, 10, 13. Now you are moving in a clockwise, different direction. 4,
For what? For which one?
9, 10.
Yeah. That's what I want to tell you. So for the front and back, you have to give the clockwise, anti-clockwise direction. Then only it will patch.
Yeah, yeah. 9, 10, 13, and 14. Yeah. Mm-hmm. Okay. 14, 13, 16, and 17. Okay. Then 10, 11, 12, and 13. 13, 12, 15, and 16. Yeah, I got it. I got it.
Okay.
Yeah, yeah.
So you have to give the merge patch pace, but here there are no patching. So these are just fixed walls. So I want to tell you. So if I have two blocks, one after another, and the flow is flowing. Just a second. Hide video panel. Okay. So home. Here it is. Yeah. Have one block and have another block. Two blocks.
Yeah, you just,
So I have two blocks, but here it will be my inlet. So this is my inlet
yeah,
and this is my outlet.
yeah.
Basically channel flow. Okay.
Uh-huh,
So these are fixed.
uh-huh.
These are my fixed walls. So on that time in merge patch pairs, we have to define these two faces, right? So
Mm-hmm,
one should be in clockwise direction, and another should be in anti-clockwise direction.
mm-hmm.
So if I define the bottom one, uh, yeah, power was gone. Are you able to hear me?
Yeah, I can.
Okay. I don't know when it will go. So yeah. So insert. Yeah, I just want to create here a block.
You can create a block with, go with the insert again. Yeah, or you just copy pasted this one.
Which one? This one.
Yeah, copy paste. CV. You will have another block.
Yeah. So I just want to connect. So
Okay.
directly can we have the shapes?
Yeah, we have a shapes. This fourth one is a rectangular.
No, not that one. Cuboid, direct cuboid.
Ah,
Right. 3D models. Stock 3D models. This one will be better. Where it went, man. Okay, so anyhow, this if you this have back side and front side, right?
Yeah.
PowerPoint not responding.
Then it's your block is coming, basically. Yeah.
Uh, Control X, control new. Sorry. Yeah, this is my one block. Control V, and how can I move it? So these are my two blocks. Delete and I will create again. So these are my two blocks.
Mm-hmm.
One above another. So this will be my inlet, this side, and this is fixed, and this is fixed. So I have on the top of one block, I have vertices, right? Suppose this is 0, 1, 2, 0, 1, 2, 3
Okay.
on the bottom block. On the top block, it will be something around 7, 8, 9, 10. 7, 8, 9, 10. This will be 0, 1, 2, 3, 7, 8, 9, 10. So if it is clockwise direction on the bottom block, it will be anti-clockwise direction on the top block. Okay.
Did we did like that? Zero, one.
So here, just give me
Yeah. 9, 10. Supposedly we did on the one bottom one is a 9, 10,
1,
0.
2, 3, 4. Okay. For clarification, I'm writing here 5, 6, 7, 8. Okay.
Yeah.
So if in the bottom wall, so if it is clockwise direction, anti-clockwise direction 1, 2, 3, 4. So it has to be clockwise direction 5, 8, 7, 6.
5,
So
8. Okay. Okay.
starting
Mhm.
from the same.
Okay.
So then only this will patch. So these are not walls. Okay. So it is one above another block. So but there is no wall or anything between them. So
Yeah.
on that case, we match patch where pairs will be there. So here we have to define these patches. So this we can see while we are solving for channel flow. So but remaining all, if any walls there, front and back should be clockwise, anti-clockwise direction. Okay.
Mm-hmm.
So this is the one way of method of doing it for the for getting this one divided into four blocks, and we are getting in one way. So another way will be multigrade. I want you to try that one. That will time taking, and another way in simple way also we can do it. So for that we have to see the multi-grading.
Mm.
So number of
Mm-hmm. I can't hear you. see you.
Okay, I lost the internet connection. Okay, so in multi-grading for any particular direction only, we have to define like a
Yeah,
number of partitions and the number of cells and expansion ratio. Okay,
yeah, yeah. I was asking that you can share the screen. I can't see it.
yeah, not able to see. Okay, now
Yeah, no, no. Yeah, now yes.
so here for multi-grading, so here in the block mesh date we are seeing in the simple grading this the first one indicates x direction, second one y direction, third one is z direction. So in multi-grading for x direction only we are giving a partitions. The syntax will be three. So syntax will be like this for x direction. And for y direction we have to define another three. So in the x direction the first one indicates a number of partitions. So here partition 1, partition 2, partition 3. So the total will be 100%. Okay.
Mm-hmm.
So here 0.2 plus 0.6 plus 0.2 equals to 1. Okay. So this will be
Yeah,
number of cells. Second one
this is
is
an
number of cells. This is
okay.
also 100%. Third one is the expansion ratio. So here, so for this image, see, so for this image, so I want to divide my x. Sirf in only in x direction, I have to divide into I divide it into three partition here for taking. Okay. So this
Yeah.
is one partition till this line. Can I have like edit option or any pen option? Cancel.
You can have a pen option. I think three. Yeah,
So this is where we can divide this one for this case. So here it will be number of partitions will be three.
yeah.
One, two, and three in x direction. So the number of cells, the total is 100 cells. We can divide how many cells we want in the first partition and how many cells we need in the second partition, how many cells we need in the third partition as well.
Yeah.
Okay. So here 0.2 indicates in the first partition I did 20% for out of 100%. And here I
Oh,
need 60% out of 100. Here I need 20% out of 100.
okay.
So here in this partition, the expansion ratio is increasing because in this partition, only particular in this, the action of this partition is should be sometimes of the x naught of this partition. So here I give it as a 4. So the this cell, this cell is 4 times of this one. So in the second partition, I need 60 cells. The expansion ratio is 1.
The uniform.
Yeah, this will be uniform of mine. And third one, I need only 0.2% of the distance. So here, so the syntax will be the first one. This thing is there, right?
Yeah.
This will be distance. So if we take total as 100,
Then 20, 50, and 20, 25, 20. Yeah, I
no, no, no,
understand.
no, no, no. This is 20 centimeters. If total is 100 centimeters,
Yeah,
this is 20
it's 20,
centimeters. This is 60 centimeters, and
and
this
this
is
is
20 centimeter.
yeah.
So here it indicates total number of cells. So here I need 25% cells of out of 100. So here I will get 25 cells. Here I will get 50 cells, and here I will get 25 cells. and third one. This is the our expansion ratio. So here it will be uniform, and here it will be xn of the third partition should be 0.25 of x1 of the third partition. So
So,
similarly, we
how about the second one? Like you mentioned, like 25% of the sales here, 50% of the sales here.
yes,
So
yes.
how we calculated this number or how we defined this
We
number?
can give anything. So if you want, we can change it to 0. Here I can give 30%. I can give 40%. I can give 30% based upon the area which we need to simulate.
Yeah, but
There is no theory behind it why I given only 25% in the first 15 second, the 25 in the third. Because it's better easy for understanding if we divide it into zero 0.2 0.2 here, the cells will be same. That will be somewhat uniform, structured. Anywhere it is structured, structured mesh only, but it will be easy. So that distance here it is 60 centimeters, right? That's
uh-huh.
why I thought of giving more cells. Here only 20%. Here only 20 centimeters. Here also 20 centimeters. That's why I thought of giving only 25% of cells.
So how many are we giving the total number of cells? Have we defined it like in a block, like a hex? No. If we can see, do you have the file for this
This
to
one,
show? Yeah.
auto search.
So before that, like before making
Yeah,
this in division, so we already give total number of like cells in X, Y, and Z direction. I just want to ask.
sorry.
Before like defining in this manner, do we mention like the total
Number
number
of
of
cells in. No, no, no. We haven't mentioned.
we have not?
Base.
Yeah, we have.
We have not mentioned. So based
Okay.
upon the length only, it will take. So
So
initially we
like
mentioned the side of the cuboid, right? Side of the block.
on the side of block we mentioned like 2021 like last
Yeah,
time.
yeah.
So out of 20, this is 30% out of
Yes,
20.
yes,
What- Yeah,
yes.
okay. I got it. I got it. Thank you. Okay.
So here in any block must be mentioned here 20, right?
Yeah.
In this 20, the simple grading will be done.
Okay. Okay. Okay.
In the 40, we will do the simple grading. This will be syntax. I should have one, but so
Okay.
let me check.
Uh,
No.
this again a block mesh. Multi-block.
Yeah, see here.
Yeah. Yeah.
So, so in the z direction, if we are giving solving only for 2D, that's why we are giving the z direction only one. Okay.
Yeah.
So
So
be
yeah,
so
20, and if yeah, say you say 25%, that means
so the difference here is here one is there, right? For this one, we divided into these partitions.
yeah, yeah, I can understand right now.
Y1 we can divide into this one, and Z is one. Here is also one. Okay.
Yeah, I can understand. Thank you. Yeah, that is one. Z is one.
Yeah. So in this way also we can do. So I just wanted to try the both the ways.
Yeah,
Here we don't. Here we don't need to create multiple blocks. Here we can
mm,
only with the multi-grading we can only create with single block. Here see X is only one. Just like a small basic cavity of how we have like seven vertices. 0, 1, 2, 3, 4, 5, 6, 7.
Mm-hmm.
In the single block we created, but here, uh, where is the previous one? Previous one. Okay, we saw multiple things, right? 4 blocks we created. That one I showed you. Hello.
Yeah. Yeah. We created this one, the
Uh,
multi-credit.
yeah, this one. Like 4 blocks we created here.
Yeah. We created a four blocks.
There is no need of it. If you can do with multi-grading. Only one block, we can divide the uniform direction partitions into 3 parts, and we can give it the number of cells and expansion ratio. So then this will be easier, but
Yeah,
it
it's
need, yeah, we need little bit attention on this simple grading, how we want to divide and how we can want to give.
uh-huh.
So
Yeah,
I so sorry,
this is much easier. The one that we did multi-grade in the last one. This one, the left one.
this one, right?
Yeah.
Yeah, that is much easier. So, but before going directly into the multi-grading, I just wanted to try this one as well. So it will be an hands-on experience for you
Yeah,
for
you're right.
basically vertices giving how front and back, clockwise, anti-clockwise we are defining. So if we define one face is clockwise, the opposite face or back face of it should be anti-clockwise. Similar with all the cases, inlet, outlet, top wall, bottom wall, front and back, left side and
Mm,
right side. So if you are giving left side clockwise direction, the right side of the fixed wall should be anti-clockwise direction. So if the top side is the clockwise direction, bottom side will be anti-clockwise direction.
right. Yeah, I think you should send me those both the notepad file. I will try to practice more on those to see.
You want me to send the notepad files?
Yeah, these two notepad files because I will run it. I will see it and then I will try to emulate, copy those.
So if you want me to send it, I will send it. There is no problem. But if you try and if you'll get any doubts, then it will be easy. If I already provided the solution, if you want me to provide a solution, I will provide the solution. But the thing is, you can't able to find the errors. So I want you to find the errors on the initial stages, so that it
Okay,
will be easy for you to why you are getting an error. So
okay, okay,
if you try, if you have any error coming up with the directions or anything, you send me in the WhatsApp messages. I will see and I will reply back to you.
okay. That's great. That's great. Okay,
So
move.
if you still find the issues, I will directly send you the answer sheets as well. So there is no problem for it for me to send you, but you won't able to find the errors if I already provided the solutions.
Okay, no worries. Yeah. Okay.
So this is multi-block. Uh, this is what I am trying to say, explain here with the multiple blocks. So in multiple blocks, we have to merge pair. Block 1, block 2. We have to merge it. This face is there, right? This is called
Yeah.
face merging. We have to merge the face of block 1 with the face of block 2.
Mm-hmm.
So here, what I want to say. So here it will be uh, 0, 1, 2, 3, 4, 5, 6, 7. So here the face of 3, 2, 6, 7 will have to merge with 8, 9, 13, 13, 12.
Yeah.
Okay. So we have to create the blocks, excess of 2 blocks, 0, 1, 0, 1, 2, 3, 4, 5, 6, 7. And same here, it will has to go 8, 9, 10, 11. Here it is 12, 13, 14, 15. Okay, 2 blocks we defined, and the faces we have to define the type of walls. So this will be all the faces. So midge patch pairs, we have to give the interference 1 and interference 2. So this phase and this phase. So that will be clockwise and anti-clockwise direction. I haven't
Mm-hmm.
there here, but so here, if it is the top of this block, 3, 2, 6, 7. If I give it like this, interference 1, 3, 2, 6, 7, it is clockwise direction. And here it has to be anti-clockwise direction. So this will be my, oh, sorry, this will be my 8, 12, 13, 9. Okay. This will be anti-clockwise direction. This will be clockwise direction. That I has to give in the midge patch pairs.
Mm-hmm.
So once you clear all the three problem statements which I told you to run, one is creating four blocks in a single cavity to check how the phases are doing. That is the one, and another one will be multi-grading. And after that, we'll go with you divide the cavity problem into two blocks and match the patch pairs and run the same problem, cavity problem itself.
Mm-hmm.
So try these three, and if you find any errors, just let me know. We will connect and we will discuss. And once you are done, if you want me to send the any problem files with answers, I will also send you.
Yeah, okay, okay. I will try this one probably. Yeah, okay,
Yes.
that's good. Okay,
Yeah.
yeah, okay,
Okay, Ji. We'll leave for today.
okay, no problem. You can-
Yeah.
Okay,
We'll connect you tomorrow.
okay, bye.
Okay.